Good day. Welcome to my weather data gathering unit, an Arduino project, which I have labeled the WeatherView 2020. This will be a short discussion on the methodologies I employed to reach the point of a working prototype, as well as showing the prototype and its operation. The WeatherView 2020, my Arduino-based project, a simple unit that is designed to be left in the field, gather data, send it to ThingSpeak, which then makes it accessible to the user via smartphone or tablet, which allows them to access the information and make accurate and timely decisions to employ scarce resources. The system concept is this. The hardware here is an Arduino-based unit using Arduino as an intelligent sensor hub. It gathers data from these various sensors along the way here. It assimilates the data, packages it as correct, displays it on the local LCD, sends it via SigFox to the cloud. Then we access cloud-based part of the unit. It pushes the data to ThingSpeak. MATLAB does any scaling and correction that we need, moves it to the display channel, which is then available via a smart device, be that smartphone or tablet. As we mentioned, the Arduino unit is the intelligent sensor hub. All the other sensors are a peripheral to that. They send information to that. It is processed and packaged there and sent to the SigFox unit for uplinking to the cloud. There's also a local LCD display to show the data that is gathered, and currently it's powered via a battery module. The software to achieve this is an iterative process. We enter into the program, we decide if it's an initial condition or not. If it's initial, we do the setup. If it's a running, we go through running checks. And at both points, we get to the timer that determines when we need to interrogate the sensors. We do so. We publish the sensor data to an array, and we move it along to this point here. That point there, point A, is then the beginning of the communications, which is this area here, where there are certain cyclical checks to ensure that the communication is correct. Some of that is built into the Arduino, and some of that is built into the SigFox unit, which does allow some of the communication to happen very simply once one understands it. Then once this is all those checks are passed, it is then published via API to ThingSpeak. ThingSpeak, I apply a MATLAB function. It removes any scaling, it reassembles the MSB and LSB, and publishes it to a public channel, which is then accessible via smart device, be that smartphone or tablet. As alluded to previously, I have called the Arduino the Intelligent Sensor Hub. It uses a low-cost Arduino unit that has a fair amount of built-in processing capacity, as well as being optimized for peripherals or having I/O. It allows us to do simple calculations, formatting, and package the data to make use of the message size that is inherent in the SigFox network in the most cost-effective, or in the most effective manner to get the most use and value out of the small messages there. We're looking at a 12-byte uplink and 8-byte downlink. So here I've used several components, and we will go through them now. As we have mentioned here, we're recording the Intelligent Sensor Hub. The Arduino is the heart of the unit. It allows for the processing, all that type of stuff. Then there's the SigFox unit here, the communication board, as I mentioned, small communications, 12 bytes up, 8 bytes down, but very cheap and very simple to use once one understands the thinking process. I have used a D1 LCD button shield, which has an LCD as well as some buttons for engagement during setup, but also to show the data to ensure that it is correct during setup. And then we have several sensors here. We have the DHC22, the D18B20, my little analog wind turbine, an analog continuous turn pot. These sensors gather the real world data and provide the intelligent sensor hub that is provided by the Arduino unit. Here's a short discussion on the various component parts of the unit as discussed. Here underneath the LCD shield is the Arduino. We have the SigFox communication board in the background there, a small PCB. We have the DHC22 chip there that does both humidity and temperature. I have the D18B20 one-wire temperature sensor right there. I have a potentiometer, continuous turn potentiometer with a wind vane for direction, and we have the wind turbine. Here is the unit. We're about to turn it on. Bear in mind that in normal conditions it polls only once every 10 minutes and sends a message. For the purposes of demonstration, I have changed that to once a second and disabled the message send. We will do so. We will enable it again shortly and look at the things peak send. But at the moment, we are purely going to examine the local data. Here we see the unit booting. It will take about 6 to 8 seconds. Establishes comms. There's a LCD test. It's getting the data. Initial cycle. There we go. There we go. We now have some sensible data. And I will now simulate and there we've seen that the wind speed and directions change. I'm now going to heat up the temperature sensors and we'll see a temperature change. Now re-enabled the message trafficking, hence the delay in the sending here. It's waiting for acknowledgement from SigFox to show that that's been done. I'm going to once again just showing some data there, and then we will go across to the things. I have updated the software to allow for the message traffic to occur, and as we see here, we are now going to simulate some speed. The message will flow through and we'll follow the message on its entire path. Alright, here we go. We're going to simulate some and here on Things Peak we have wind data of was it 7, 10, 5, yes. There. And here on Things Peak we have the latest wind data, which was shot now 2 minutes ago. And we see there the timestamp is correct and the wind speed was in fact 5. Furthermore, we can also see the temperatures have changed. The timestamp. And as we were using the dry air, the relative humidity has gone down.